this, the two most important things that you really need to know is how to solve problems, whether they're mathematical or not, and how to collaborate with others in doing so. So because of that, I've implemented a way of solving problems in my classroom that enables students to do both. There was a presentation by the Gates Foundation that demonstrated how students solving the problems at the same time, all around the room on boards, really did help each other, because not only did they collaborate with each other, but they were able to look around the room and to see how their colleagues were solving problems, and they're totally allowed to do that and very encouraged to even talk to other teams in using this problem-solving strategy. As this is not an assessment, this is how would we solve problems in the real world. In the real world, you would collaborate with multiple people to get there. The other piece that we added to this is what we call the gallery walk and the follow-on discussion. And the reason we do that is so that it enables them to see how did their classmates solve the problem, and to come back and to talk about what did they feel was the best way, what way helped them the most, whether they're explaining the problem, whether they're solving the problem. And that shows them that oftentimes I'll say to them, if we were writing a collaborative paper, what pieces would we pick out of this as a group and a whole? And it teaches them to give constructive comments to each other, and it teaches them, maybe even more importantly, how to take those constructive comments and go back and reflect and refine their work. And what I have found over the course of time doing this is that students really are getting better, and they'll change the way that they either lay things out or describe things based upon what they've seen their classmates do and things that they like. And this is the change in the number of passages. What does that mean? Okay, so you guys define each one of your phrases. Yeah. See, because it's always our change in our dependent variables or the change in the independent variable. So what did you find your change
my using the variables, it would be -5 over 3.
Okay, so does that help you? But then what are you going to put here and what are you going to put here?
That's what we're trying to figure
Okay,
out.
so what typically goes there? The independent or the dependent variable? So you know what might help? What could you say up here? C is taking place of what we typically call what?
X.
And B is taking place of what we typically
Of the
call
Y.
Y.
So
Because
it would be B
independent.
equals -5 over 3 C
There you go.
plus the Y-intercept, so 120.
Okay, does that make sense now? It's a little bit hard when we change variable names, because then that becomes a little more challenging. But that's when we want to keep together what's independent, what's dependent, and sometimes putting this above that helps you to kind of keep that in the right
Okay,
way.
and
Okay, should write what it means too.
And then explain what it means in the context of this one. Could you interpret that two ways? Right, so I just want you to indicate that so that you understand that. Or you're saying, right, as the number of group years decreases, the number of passages increases by 5. Or you could even take another color and write that. One is increasing and the other one decreasing. Right, like increase or decrease in another color. Does that make sense? Which team's representation do you think would explain it the best? And if you have a question on what anybody did, you're just going to put a question mark. That's it. You understand? So now we're going to go twice, as we do. We're going to look once and take in what people wrote. I'm going to go vote and say, you know what, I think this team's representation really makes a lot of sense to me. Now, because you did two different forms of the equation, right? You did a standard and a slope-intercept. You could vote two different teams for that. Because one team you may feel did a really good job explaining that standard form, and another team, different team, may have done a better job at slope-intercept.
It means so when the number of corsages made increases by 3, the number of boutonnieres needed to use all 360 stems decreases by 5.
Okay, do we agree with that?
We didn't do this, but you could have, if you looked at the x-intercept and the y-intercept, and you did y2 minus y1 over x2 minus x1, you could have figured it out by the 2 points.
Okay, so you could have picked any 2 points, excellent, from your table. Could have been the x, y intercept, could have been other points?
Yes.
And the second piece of this is how do we tie this to the Shepaug Learner Outcomes? And the students were hearing these outcomes but not necessarily making that connection. So what we did was we took one day to talk about our core values and guiding beliefs and where they came from, and explaining to them that it's every teacher's responsibility to enable them to live the Shepaug Learner Outcomes, because they're not only good within the walls of Shepaug or within a single solitary classroom, but they're going to take those things that they're learning and use them in the outside world, whether they go to college, career, or both. So at the end of the class, we like to tie back what learner outcomes we've used, but the students don't just say what they've used, they have to explain exactly how they've used those in the context of what we did during that particular day. And I have to say, they always impress me with what they're doing.
I think we did a lot of reflection and refinement, because after we did everything at the board, we would come back and discuss it in the center.
How do we use structure?
Because you have to, like, making tables and doing the correct equations, but also, like, we learned how different structures can be the same answer. Like in the slope, how 3 over -5 is also equal to -3 over +5.
Okay.
We used reflection and refinement because when we did it on the board and then we did like a gallery walk and walked around, we looked at other people's answers. And if we had it wrong, we realized that what we did wrong and fixed our answers to
Okay.
refine them.
Excellent. We went back and adjusted it.
Evaluation.
How do we do evaluation?
Well, we obviously solved the problems. So, we also use like different ways to solve problems.
Okay.
We did a lot of defending conclusions and judgments.
Okay.
In this problem, we all had a lot of different answers, and we all had a lot of different like responses to the problems, and I think we kind of all combined figured
That information.
And then evidence in defense, because we had to show what we thought and then give evidence to see what we're doing.
Problem solution.
Problem solution. How do we do that?
We solve problems.
Okay, so we solve problems.
Yeah.
James.
Problem clarification. When we came
Problem
back to the middle.
clarification. I'm sorry, say again?
When we came back to the middle.
Problems, we did a lot of evaluation.
Okay.
To defend
How?
our point. Well, we had to defend our reasoning, because once again, all of us on the graph had different points. There wasn't a given number that you had to choose.
Okay.
In the creative process a lot because we made connections to how it would work in this situation.
Michelle.
Evidence to like defend our answer.
We answered a call to citizenship because we did a lot of collaboration, with finding the board that we thought best represented the problem.
The tie finally to Common Core is the fact that when you're looking at Common Core, it's really having students discover learning themselves, working together, looking at how this learning is applied. In the past, math problems typically were done very algorithmically, where the students would solve things algorithmically, and if we had time, we went and applied those to a particular word problem. But what they're doing now is they're actually starting with the problem and pulling in the tools that they need based on prior knowledge and new learning and saying, how do I solve this problem? Which definitely is way more connected to what they're going to be doing within the walls of Shepaug and beyond the walls of Shepaug. So our goal really is to get them college and career ready, not just in this classroom, beyond this classroom, by tying this to the learner outcomes that we're all striving to achieve, and by incorporating the lessons and the methods of teaching with the Common Core.